Hello and welcome back to another video. Today we're going to be looking at Calc Bc Free Response number 2 in the 2019 AP. So we're given this continuous function f, which they say is defined on the closed interval -6 is less than or equal to x is less than or equal to 5. The figure above shows a portion of the graph of f consisting of two line segments and a quarter of a circle centered at point 5, 3. It is known that the point 3, 3 minus rad 5 is on the graph of f. So right off the bat, let's highlight, let's see, two line segments could be useful. Quarter of a circle will definitely be useful. Let's put that in a little red circle right there. And it's centered at the point 5, 3. Well, let's just put a little point right there. All right. It is known that the point 3, 3 minus rad 5 is on the graph of f. Okay, so let's also put that point there. Here's 3, and this is going to be point 3, 3 minus rad 5. Right. Now that that's out of the way, let's get to the question. Part A. If the integral from -5 to 6 of f of x dx is equal to 7, find the value of integral from -6 to -2 of f of x dx. Show the work that leads to your answer. All right, so let's draw a line over here. This is going to be -6. This will be 5. And this we'll say is -2. All right, so if the integral from -6 to 2 is what we're trying to find, let's call that I for integral. And this from -6 to 5 is equal to 7. And then all we need to do is find this. And then we can just say 7 minus whatever this thing is equals I. So first we need to find this integral over from -2 to 5, right? So let's do that. All right, so if we're starting at -2 and we're looking at the area here, we can see that the area here and the area here are going to cancel. So these are just they'll cancel out. Then this area here is going to cancel with this area here. And you can just tell this by looking at it. And then let's say this area over here, this triangle, is going to end up going over there to become a new triangle that connects with this rectangle, which is actually a square, and this other square over here. So it looks like we have a total of 2 units so far. Then we're looking at this area here, this kind of square that goes from 2 to 5, and that's that. And how are we going to find this area over here? Well, what we're going to do is we know how to find the area of a square. That's 3 times 3 equals 9. And then we have this circle over here, right? And the circle, we know how to find the area of a circle, obviously. Area equals pi r squared. Well, this is a quarter of a circle, so it's going to be pi r squared over 4. That should be equal to pi times, and what's the radius? The radius appears to be 3. Pi times 9 over 4. So that'll be 9 pi over 4. Right. So now this entire thing is going to be this entire area, this entire integral will be equal to looks like it's 2 plus, that's 9 minus 9 pi over 4. That should be equal to 11 minus 9 pi over 4. So there we go. 7 minus 11 minus 9 pi over 4 is equal to I. So we get -4 minus 9 pi over 4 equals I. And let's see. Looks like it's negative 16 minus 9 pi all over 4 equals I. So hopefully that's correct. In reality, on the Calc BC exam, you could just leave it like that because they take calculable form. And in fact, that's what I did. So yeah, this looks like this over here looks also like it could be right though. So let's just say it is. All right. So on to the next question. Part B. Evaluate the integral from 3 to 5 of 2 times f prime of x plus 4 dx. All right, so let's do it. This is going to be 3 to 5, 2 times, and that's f prime of x dx plus integral from 3 to 5 of 4 dx. So let me scroll down a little bit here. F prime of x. All right, so here we're going to end up getting 2 times f of x from 3 to 5. And here we'll get just 4x, and the 4x is going from 3 to 5 as well. So, well, let's check out f of 5 and f of 3. F of 5 appears to be 0. F of 3 appears to be 3 minus rad 5, because they gave us that point. So we're going to get 2 times 0 minus 3 minus, does that say? Yeah, that said rad 5. Okay. Not 3 rad 5. Rad 5. Rad 5 plus 4 times 20 minus 4 times 15 is 80 minus 60 is 20. All right. Or wait, I did that wrong. It's 4 times, yeah, it's 20. Just 20 minus, okay, I definitely did that wrong. It's 20 minus 15, right? Or 20 minus 12, 20 minus 12, which is equal to 8. All right. And I could do this out, or I could just leave it like that. I think I'll do it out because I care. So this is going to be negative 6 plus 2 rad 5 plus 8 is equal to 2 plus 2 rad 5. All right, that looks right. Now on to part C. Okay, for C, the function is given by g of x equals, function g is given by g of x equals negative, the integral from negative 2 to x of f of t dt. Find the absolute minimum, the absolute maximum value, okay, something we should highlight, absolute maximum value of g on the interval negative 2 to 5. Okay, so if we're looking at, it appears that we're looking at just the function of the integral. So we're going from, all right, looks like we're going from here, this is just g equals 0, because its integral from negative 2 to negative 2 is going to be equal to 0, all the way up to 5, and we're looking for, that'll be g of 5 is equal to integral from negative 2 to 5 of f of x dx, I think, is that what it said? F of t dt, whatever, it doesn't really matter. Yeah, so we're going to find the absolute maximum value of g. Right, well, this is just the integral, and as we kind of looked at before, we've got, these two cancel over here. These things cancel over here. This becomes 2. So it looks like right now we've got a maximum at 2, but wait, there's more. Over here, we've got another bit of area, which is going to be your, over here, this is 11 minus 9 pi over 4. And then over here, this looks like this is going to be the maximum. And I think, you know, you could justify that in another way, but in reality, just like look at the graph, you know. You can get a 5 with 50% on the AP, and I think this is one of those things that you just don't want to spend time on justifying. So you're just going to say absolute max at x equals 5. And I think that's fine. That's basically what I did. I might have made up some kind of BS justification for that, but really it doesn't matter. All right, next, part D. Find the limit as x approaches 1 of 10 to the x minus 3 times f prime of x over f of x minus arctan x. All right, so we could plug in 10 and see how that goes. I'm not sure if it's going to become 0 over 0. We might not even have to do L'Hopital's. Let's just plug in 1 and see how it goes. All right, 10 to the 1 minus 3 times f prime of 1, f prime of 1 over f of 1 minus arctan 1. All right, so that looks like 10 minus 3 times, well, what's f prime of 1? F prime of 1, that looks like it's positive 2. 10 minus 2, well, we're not in 0 over 0 form now. Oh, wait, it should be 3 times that. I'm still not in 0 over 0 form. All right, and then f of 1 is 1 minus arctan of 1. Well, we know that arctan is, well, we know that tan of pi over 4 is 1, right? Tan of pi over 4 equals 1. Therefore, arctan 1 must equal pi over 4. So it's going to be equal to pi over 4. And this is an acceptable form to leave it in. But again, I don't want to, I'll just do it out because I don't really have anything else to do with my life. All right, so got 4 over 1 minus pi over 4 is going to be 3 pi over 4. I think anyway. Does that make sense? 1 minus pi over 4. No, of course it doesn't make sense. There's no way that makes sense. All right, I'm just going to multiply everything by 4. 4 minus pi is going to become 16. And then, yeah, that's fine. That's probably fine. All right, so that's the answer. And there we go. Everything is done. Right? Thank you for watching, and I'll see you next time.